Uh, Hello YouTube, and let's continue the advent of code. And let's go with exercise number 4. Also, how's my VM doing? Okay, so we are where we left everything. Cool. So you can already create the new folder. So you know what? I should like cd day 4, and then I can start touching stuff. There we go. Okay. Exercise number 4. Giant squid. Okay. You're already almost 1.5 kilometer, almost a mile below the surface of the ocean. Already so deeply you can't see any sunlight. What you can see, however, is a giant squid. Okay. Oh, it has attached itself to the outside of your submarine. Maybe it wants to play bingo. Of course. Of course. So bingo is played on a set of boards, each consisting of a 5x5 grid of numbers. Numbers are chosen in random, and the chosen number is marked on all boards in which it appears. Yes, numbers may not appear on all boards. Yep. If all numbers in any row or any column of a board are marked, that board wins. Diagonals don't count. The submarine has a bingo subsystem, of course, to help passengers, currently you and the giant squid, pass the time. It automatically generates a random order in which to draw numbers and a random set of boards, your puzzle input. So for example, okay, these are the numbers that are going to be extracted, and these are 3 boards, I guess. After the first 5 numbers are drawn, 7, 4, 9, 6, and 11, there are no winners. The boards are marked as follows, shown here adjacent to each other to save space. Yes. Okay. After the next numbers are drawn, there are still no winners. Finally, 24 is drawn, and 1 board wins, which is this one. Okay. At this point, the 3rd board wins because it has at least 1 complete row or column of marked numbers. In this case, the entire top row is marked. The score of the winning board can now be calculated. Start by finding the sum of all unmarked numbers on that board. In this case, the sum is 188. Then multiply that sum by the number that was just called when the board won, 24, to get the final score. To guarantee victory against the giant squid, figure out which board will win first. Why do you have to guarantee victory against the giant squid? Is this like a situation where it's like one of those gambling Japanese animes where like if you lose, like you die or something? I feel like this story took a weird turn. Like it started with, oh, you're underwater, but there's a giant squid, but then he wants to play bingo, but then you have to beat the giant squid for some reason, like at all costs. Okay. Okay, I get the puzzle input. So this is interesting. I am frankly kind of tempted to split this puzzle input in 2. No, it doesn't matter. I can just take it here and it's fine. Is it though? Hmm. Yeah, I think it is. Okay, day 4. So here's our board, here's our numbers, there we go. I think I want to steal something from day 3, like the usual boilerplate. I think I will want an locator. Do I want a hash map this time? Oh god. Okay, so we have to reason about data structure this time a little bit better than what we did last time, and what I did last time. But before we get there, we can already start parsing this data. So I think we should split by new line. And then we special case the first line. I always feel that keeping the input file intact is part of the puzzle. Parsing stupid input files is part of the fun. I mean, yeah, but I don't know. I don't mind cheating when it actually gives me saves me from some boilerplate. But at the end of the day, this is gonna be super easy to do, so I don't worry about it too much. So let's have the main iterator do new lines. Mem.tokenize bytes. We tokenize input, and is there anything else? Yes, the separator, which is new line, the limiter thingy. So this is gonna give us the first line. So var or const Can I do it like this? No, you know what? Numbers, and we can do it all at once, I think. Can we? No, I don't think we can. So I want to split on commas, and that's gonna give me a lot of slices. I did new line, so it splits the draw and each separate board. Is it like 2 new lines? Oh, you're right, it's 2 new lines. The problem is that, so if I use tokenize and I put 2 new lines, it's not gonna work. So I don't know, Nathaniel, maybe you already meant the right thing, but okay. And you yeah, you need to use split. The point is, if you have multiple thingies in here with tokenize, they are like in or. It's like one or the other. If you want only a double new line to be the separator, then yes, you need split, which might be a good idea. Yeah, I see no reason not to do that. We can do that, and it works. But yeah, that's an important difference between tokenize and split. Oh, nice. So I was right. Yeah. It happens. Okay. So numbers. I still have my notifications up. Sorry. Okay. What's a neat way of splitting all these numbers with a comma? Because split and tokenize, do I really need to do like an array list or something? Do I have like something that counts the instances of a character in std.mem? So I can maybe allocate like I could use an array list, I guess, or something like that, but maybe I can be a little bit more precise with this. std.mem tokenize it on next. Yeah, I can do this, but that gives me an iterator. I don't know, do I want an iterator? Somehow I kind of wanted like to have an array of numbers here. Because I think I'm going, am I going to run through them more than once? No, I'm not. So you're right. I could actually tokenize them as I go. I don't actually need to have a prepared numbers array. Okay, so let's assume that we do this. So numbers, let's call it numbers line. So we have numbers line. And we don't parse it for now. Who cares? Let's talk about boards. So we have all these beautiful boards here now. What do we do with them? How do we store them? We need to keep track of it's okay. It's clearly a double array, right? A 2D array. We need to keep track of row and column. We need to make sure we don't mix them up. Or actually, I think it doesn't matter much if we Yeah, it doesn't, because even if we transpose this by mistake, everything will still be valid as it was before. So we don't have to worry much about that, except that probably part 2 is going to make that important. That's my worry. So in any case, we have the matrix, and then we need a function that that keeps track of this stuff. So how do we do this? Although if I have the numbers all in hand, as I build this, I can check it against this. I can, as I build it, so I can build it already with and also I can build it and I don't even need to store numbers. No, I do need to store numbers because they are required. Because I'm required to sum all the ones that aren't selected, right? That haven't been extracted. Multiplied by the final number. Okay, so like there are ways of like not computing this without simulating the extraction, right? You could somehow say all the numbers were already extracted, and as I parse these numbers, I only mark them if they're present in this set. But then this cannot be a set because we care about ordering, because to compute the final result, we care about which was the last number in this sequence that matched with this. So this could actually, so this is funny because this would actually be a very nice exercise to solve with Redis, because you could have like a sorted set and you do set intersection and then you look at the sorting order after having done set intersection. So that could have been cool. For us, it's not worth it. We don't have the appropriate data structures, and making them, it's definitely not worth it. So what I'm gonna do is parse all the matrices, not write anything down for any board except, well, the numbers, and then I'll run through the numbers at the end, doing like a proper fraction simulation, I guess. Okay, so I think we can make a board struct for this. Are they called boards in Bingo? What are they called? Yeah, they're called boards. Interesting. Okay, cool. So, okay, that wasn't me pressing the button. So our board is gonna be a struct that has well, numbers, which is going to be a cute double array. What is it? 5 by 5. I have to look at my input data because I can't trust that one. 1, 2, 3, 4, 5. Yeah, 5 by 5. 5 by 5 numbers. So we could put a number there and be done with it. Also, these are like are small numbers. Probably a byte would be enough. So we could make it a U8. The problem is do we want to associate more data with each cell? So we can make a cell, another struct, or so, I don't know, let's call this data, generic name. So we have the number, which is a byte, But then we also have like a boolean that says whether it was selected or not. Whether it was extracted or not. Hmm. Do we want that? So I could do that, but then if I do this, I'm not too afraid of doing inefficient things because I think that Zig is going to be able to power through it without much trouble. But I'm starting to wonder, like, maybe I should, instead of caring about whether instead of storing this information for each cell, I could probably already store this information by column and by row. It uses a bit more data, but it saves a lot of checking back and forth, which is probably worth it. We memorize some stuff. Memorization is cool. At least in this case. Hello, world's slowest sim racer. Hello, hello, hello. Do we have duplicates in here? So if there can be duplicates in here, it's a problem, but I don't think that's possible. Like in normal bingo, there are no duplicates, so we can assume there are no duplicates, which means that, okay, then let's have our numbers be normal bytes. And then we can do row matches. And it's just an array of 5 to 8s, also it's fine, I guess. And same with column. So the idea is that basically every time we match a number, we increment by 1 the number of matches for the row or the column corresponding to that cell. That way, if we want to check whether a given board has a full row or a full column or of matches, we just need to find inside this array if something has value 5. And at that point, we don't need to do all the checking in the entire array over and over. I think this is worth it for simplifying the code, mostly. And then we also need to keep in mind what the latest match was, right? Yeah. Let's go with the last match. Okay. I think we are good. So, and this is undefined. This should be a bunch of zeros. This doesn't matter. So we can put it to undefined, I guess, maybe. Also, what is this, a dot? Okay. So we have our board, and so while there are more boards, well, let's call it line. So for each line, what do we split on? On space and new line. tokenize, always bytes on a line, and we tokenize on space or new line. Okay, so basically what we want to do is want to fill our matrix. Man, I'm gonna mess up indices and rows. I'm so confident I'm gonna mess it up. So okay, let's have our indices drive this part of the computation. So var usize var j usize. So we want to fill. I think these are stored by row, right? Oh man, I don't remember. So array 0 0. So we can say that 0 0 is this. Then this should be 0 1. We do row on the outside. Let's do row on the row major. Row major it is. So while I is lower than 5, we keep incrementing I. And as we increment I, we do the same with j. And we do, oh, we need also to allocate a new board because we don't know how many boards there's going to be. How do we do this? Maybe I could cheat by counting, but no, let's allocate them dynamically. We need to put them in an array list, right? So let's create an array list. Dot array list, I think, and then it's gonna be of array list of boards, and then we init it by passing in the locator, I think. Actually, it's been a while since I used array lists last. And so also as we do this, we need to do var board equals board. Oh, we can do it like this. Wait. We need to do the property initialization. So we could do this. I could create a board and leave it to undefined. But if I set this board to undefined, I'm not going to do this cute initialization here. So setting it to undefined is mostly fine for numbers and last match, because I don't care about those. But I do care about row matches and column matches being zeroed correctly. So property initializer it is. Then in here we put stuff in the board. So board numbers. We said I on the outer layer, J inside, row major. Cool. I'm dumb. I just realized there's a big mistake with what I'm doing. So this works, but I need to keep information about which cells have been extracted and which have not. I need to keep that information around because it's gonna be necessary for computing the final result. So do I want to put extra data on the board itself, or do I want to basically run the board through all the extracted numbers? That's tough. That's really tough. I think I'm gonna add data to my data structure here. So I'm gonna say numbers have let's call this data then. So there's the number, and there's the boolean that says whether it was found already or not, and that's it. And at this point, my dreams about row matches and call matches don't matter anymore. So it's gonna be data.num. It's gonna be equal to, well, no, not .num. So this cell in data is gonna be equal to .num equals try std.fmt plus int. We said that all these values are bytes. The number is going to be what? it.next, num it.next. And the base is going to be 10. And then found is going to be true. Here we go. At this point, setting this stuff to undefined doesn't matter. Everything is undefined. We don't care about... EVFP, thank you for the raid. Hello, everyone. So... At this point, I don't care about this initialization. Undefined is good enough. Because nothing needs to have a default value. Hello, good evening to you. Were you doing the advent of code like everybody else is doing right now? It's like Christmas, but for developers. By the way, thank you for the follows, Sogi and Francis Cod 123. Yeah, in Haskell. Oh, okay, I see. Yeah, I'm catching up because I missed the first few days because I wasn't home. I wasn't home, and so now I'm trying to get back to the main program. I'll get there hopefully. Hey there, started AOC with Zig, but I fell back to Python because of my existing speed. Yeah, I see your point. I'm fine taking it slow. So here's my hope that. Well, okay, I'm doing Z because that's kind of what I do, but also my hope is that, having to deal with memory management and everything else makes AOC more annoying, but I also hope that there's gonna be some exercise down the line that is gonna like start to stress the number of iterations and like the capabilities of your computer, and I hope to get to a point where I don't need to do the optimized version because I can power through it by having like efficient code rather than high-level stuff that allocates, etc. But yeah, hopefully I'll be able to do a second pass with Zig. You know what? I think there shouldn't be any shame in even doing AOC with different languages. I guess that would require you to be, like proficient with more than one language. But hey, as long as the exercises don't stress your computational capabilities, like the computational capability of your computer, whatever, let's do it high level. Who cares about memory management? But then, okay, so you're onto something. I see. So But then when that exercise strikes, maybe you can drop down to a more efficient language and whatever. I don't know. It depends. I'm sure there's gonna be an exercise with this damn Chinese reminder theorem. That's going to make everybody's lives miserable unless they realize that that's what it is. So in my board, I'm going to put a number. I'm going to say that. Why am I saying found true? Found is false as a starting point. Then we're gonna set it true later. So with this, we parse all the boards. Actually, so here we are parsing board. Then we need to append it to our array list. So I hope this works. Maybe I should call this B. So I append the board that I just computed, and then what do I do next? And I do all the boards. Okay, I got to the end, got all the boards. What do we do now? We need to simulate extraction, right? So every time we extract a number, we have IT here. We have numbers. Oops. Numbers line. So we need to start splitting numbers line. So var. What should we call this? Let's call it numIt. We can reuse numIt because the one in here was namespaced, so pretty cool. So tokenize bytes for the numbers line, and we're going to split on the comma, right? Yes, there's a comma. Am I gonna get a new line here? No, I should not. Okay, so we split on a comma, and at this point, well, we can grab numbers. So the number is going to be try fcd fnt parseInt u8 talk. Hey Specs, hello. Hello. Okay, so we grab the number. And I guess every time we get a new number, we start iterating over all the boards. This is a fun one. So, I was originally trying to somehow, well, not somehow, I originally planned to somewhat cheat. And like, every time I grab a board, immediately run it through, like basically do set intersection. But then it requires you for the solution to care about the ordering of these numbers, and I don't know, somehow at that point I started thinking, oh, you know what, then I would need like to make this nice, I would need like a cute sorted set data structure, which I don't have, so I might as well just do the proper simulation, because hopefully I'm also worried that cutting corners on the first part is gonna force me to suffer more on the second part, so I decided to do it like the naive way, and okay, let's get all the boards, now let's do the numbers, and let's run the like extraction process. You just gave me a really good idea on how to speed it up. Yeah, I mean, with the right thing, you can do clever stuff, right? At the end of the day, yeah, not a first time solution. I agree. What matters is getting the result. At least for me, I don't care about speed. I care about just getting the result and hopefully show people that it's not insane. Also, take a look at this. Look what I got. I don't know if you can read this. I think it's mirrored. Well, it says Tiger Beetle. But I need to take it off because it's too hot. I've been drinking hot tea. Oop. I've been drinking hot tea and yeah. Okay, so so get a number and so I went to iterate over every element in the array list, and I don't remember how to get the contents of an array list. Array list? Array list. In capacity, 2 own slice. Not really. Is there like 2 slice? Not owned? I mean, I could own it. At the end of the day, it's not the end of the world. It's just like... Oh, I think it's dot items. Is that it? Dot items. Yeah. So I should be able to just do dot items. Okay. So for boards dot items. Okay, so for each board, what do? We basically need to update the board. Check win condition. I think that's pretty much it. And if the win condition happens, then we print the result. So okay, update the board. Update the board. We need to check every single item. So for boards. Oh, you know what? I'm still gonna do the index thingy. Oops. So we keep scanning the board until we find the number. Yeah, ZigFMT is awesome. It's my one religion. I'm actually very promiscuous about everything, but the one thing I think I would be able to be like some kind of priest is FM formatters in general. I loved Go FMT and I love ZigFMT. And also ZigFMT is a kinder god than GoFMT because you can negotiate with ZigFMT a little bit, so that's pretty cool. Okay, so well, we keep scanning, and as we scan, if we find a match, then we update, and then in here we check the win condition. Both were inflexible. Oh no. So here's what you can do. Here's how you negotiate with ZigFMT. Look at this, for example. Here I'm setting data to this struct, but this struct is on multiple lines because I put a trailing comma. Without the trailing comma, this stays on a single line, which is a bit too long to stay on a single line, but you can see, like, if this wasn't a giant expression, it would make sense for this to be on a single line. But then it's you decide. You put the comma, ZigFMT puts everything on a new line. You don't put the comma, ZigFMT puts everything on a single line. Oops. And you can do the same thing with function arguments, with basically everything, even function arguments when calling a function, right? Okay, this is maybe not the greatest example, but you can see how it can be useful in other cases. But also when defining functions, like in function signatures, you can do the same. And it's tiny comma and ZigFMT, you know, despite having infinite power, it will allow you a degree of freedom. Using the training comma as a hint for line by line formatting is genius. Yeah, and it also allows training commas, which are not bad. Like every time you have a list of something, like allowing you to put a training comma there is just not bad. It's useful. It's, I think, the main pain point that you experience, like going from like JavaScript object notation to JSON. It's mostly painless, except for trailing commas and keys, unquoted keys. And yeah, you get some of that from a systems program. And if you want that, apparently you have to go to a systems programming language. So yeah. In any case, so let's see if we have a match. So how do we do this? How do we do this? Yeah. So if b.data ij dot num is equal to num, then we found a match, and it's in here that we check the winning condition. RD7CC, hi, in terms of program style, how nice would it be to put some parts of functions into the board structs? Into the board struct? It would make sense to put some things in there, right? I think you're right. Like, it could be nice to put like a tiny function to say, I don't know, check for win condition for these coordinates and stuff. I think that the problem with AOC is that you don't know precisely what you're doing as you're doing it most of the time, and so you tend to write more procedural code. Also because this main solution is the first exercise, right? And there is going to be a second exercise. So occasionally I end up putting like something like, by the way, Hardy, I don't know if you're aware of this. You might, in case you're not, or in case somebody else watching is not, just to be clear, you can do that in Zig. You can do pub function foo and I don't know, void, and there you go. You have basically a function that works as a method. So you can do self board, and in there you do normal stuff, and then from other functions you can do board.foo and it will work. And self gets automatically filled out with a board instance when you call foo on an instance, because board, lowercase board, was an instance of a board right down here. Oh, well, I'm renaming it to be afterwards. So you can do that. Or you can do board.foo and then you pass an instance as the first argument. So that works. Yeah, but in this case, I don't know. For now, I don't feel like I have the need for it. But then at the same time, I don't know precisely what I'm doing. So I don't know. I'm kind of discovering what I need as I go. So we did find a match. If we did find a match, we want to set this to the proper value. So you know what I'm gonna do? I can do this, maybe. I do cell equals pointer to this. If cell.num equals that, that's cool. Otherwise, well, if so, cell.found equals true. And then we need to check for the win condition. So the reason why I need to take a pointer is because I want to mutate it. And I want to mutate the contents inside the original array. I don't want to make an external copy that then I edit, leaving the original unchanged. I want to change the original inside the array embedded inside the board. Okay, try to not only solve AOC, but try to find some kind of resolution in terms of overall style. That's reasonable. I personally have the policy that I want to stay pure when it comes to my goals. And so the problem is that if making it nice and, like, I don't know, robust isn't really an explicit goal, then you end up like with weird conundrums that don't really have a good solution, like a good answer, because what you're doing is outside of the scope. So, like, for example, I'm writing code that assumes the input is always correct and clean. Obviously, if you were to write a more generalized program that isn't just supposed to run on this input here, you want to write a program that maybe parses that input, also checking for things that don't make any sense, like numbers, I don't know, boards that are the wrong size, numbers that go outside the range, negative numbers or something, I don't know. And I don't do that because it seems outside of the scope. Also, here, for example, another thing that I'm cheating with is that I'm embedding the original input inside the executable using embed file, and that's allowing me to skip a bunch of boilerplate in the beginning where I open a file descriptor, I read from the file descriptor, I close the file descriptor, which is something that for a more general solution you would 100% want to do. So I would say that said, while I personally don't want to go down that path, it's fine if you want to, because I personally have other goals outside of what the AOC specifically is, right? I'm doing the exercises to show also people how to do them, and that's not part of the official goals of AOC. So occasionally I will make certain choices that maybe if I was only worried about getting things done, I wouldn't do. So maybe I wouldn't create a board struct out here. Or if I wasn't trying to show people a reasonably sane way of doing this stuff. But I guess it depends on the goals that you want. In this case, so you know what? I think I'll start to gear up with like namespace functions, maybe on the second part, because on the second part, what the overall end goal of this entire puzzle is going to be more clear, and maybe at that point I'll need a tiny little bit more abstraction to make things clear. It depends on how tough the second part ends up being. So we check the cell, we set it to found. Since it was set to found, maybe this board now is a winning board and we need to check. So also we need to do another thing for sure. So we need to check the winning condition, but even if this is not a winning condition, we have to do another thing, which is very important, which is we found a match. We're done checking this board. So when we find a match, we don't need to check more numbers. So maybe we find a match, the winning condition isn't there, but then that's enough. We don't need to go through the numbers anymore. So we need to break. The problem is, what do we break from? So if you just have break, you're gonna break from the inner loop, or better than nothing, I guess, but still not great. So you actually want to break from the outer while loop. So here's how you do it. Let's call it row loop. There we go. That's kind of cool. Like being able to do this. Oops. That's really useful. It's a giant pain in the ass when you can't do this. And you can do the same also for for loops. So that's cool too. Or, you know what, in alternative, it could either we break from this while loop, or we want to continue the for loop. I guess the two things are kind of equivalent. It depends on whether we put something down here or not, but I don't think we will, so I'll leave it like this for now. Okay, so check the win condition. How do we check the win condition? We don't need to check the whole board because we just modified one column, one row specifically. So these two things are the only candidates that could produce a win condition. So that's all we're gonna check. And to check this, basically, are labels only for 4 breaks? Is goto banned? Yes, there is no goto. You can use labels, or sorry. Let me... No, I think that's the correct answer. So labels are only for breaks, yes. There is no goto. Labels don't necessarily have to be attached to a loop construct. You can have a... I was showing this yesterday, I don't know if you were here, but like you can have const foo equals block, and then you have a block in here, and in this block you have a bunch of statements, I don't know, that are useful for computing foo, and then at the end you do break foo, break the foo label with, I don't know, 42 or like whatever you ended up computing with this statement. So this allows you to basically namespace a bunch of things, and you know that this entire block is basically entirely dedicated to constructing foo. And that's kind of cute. So there's another use for labels. So it's not just loops. I did this here. So this is day 3. We had to compute what was the good bit. Oh yeah, the most popular bit. So computing the good bit ended up being like this. So in a block, we do all the counts, and then after we're done with all the counts, then we break from block with what ended up being the good bit. And so I know that I can basically, with my eyes, I can immediately, like if I don't care about how good bit is being computed, I can immediately skip all this stuff. It's not going to pollute like the outer namespace. So yeah, and by the way, BLK is like usually the default name that people use. You can name this label however you want. It doesn't have a special meaning. Okay. Let's check the win condition. So boring. Can do this. We set x to 0, and while x is greater than, no, it's lower than 5, we increment x, and okay. Oof. This is more interesting. So I think I want to solve this using the else branch of while loops. Actually, I think that for loops have them. I'm not sure if while loops have them. So I need to make sure that while loops have them. So let's go check this stuff. Sometimes I wonder if it would make sense allowing to break out of all blocks, not just loops and name blocks. There are 1 or 2 cases where it would have made my control flow a tiny bit nicer, but I guess people would abuse it as a go-to. What do you mean to break out of all blocks? I mean, how do you specify break out of all blocks without putting a label, without naming it? Yeah, I mean, I was actually about to say, like, is it like the one thing that returns from all blocks is return? Breaking back to the function top level, I see. The problem is that things like if condition break now break out of the local block instead of the loop, so it's easy to shoot yourself in the foot. Yeah. I can tell you what, so everybody has their own pet thing that they want, right? I can tell you mine. So mine is that I would like short syntax to say, why do I have to come up with this label name that is unrelated to good bit, where when it's obvious that what I want to do is create good bit. So I kind of would like to do this, which I can do, but why am I repeating good bit? So here's what I would like. Something like this, or actually like this. I don't know, whatever. So basically, I'm saying, yes, this is a label And the label is for assigning this damn variable, so you know what the label name should be. And this makes what I think it's like the main use case for label blocks more terse, but whatever. Specs likes that. Nice. Specs, we can have our own conspiration about adding this thingy. So I think graphically speaking, this is nicer. But this, in a sense, is like I'm straight up omitting the label name. I don't know. In any case. Like, I don't like BLK. There's a bunch of BLK everywhere. Why are we BLKing everything? Or even colon. Ooh, only face operator. Yeah. Let me see. Nice. Nice. That would be a nice addition to the pantheon of funny smiley faces. Anyway. Okay, going back to my thingy. So let me go check the documentation for the else branch in while loops, because basically, here's my idea. I could be boring and do every time I find a match, I increment a counter, and if the counter equals 5, it means that the entire row or column or whatever has matched, and then we're good. But I want to exercise a language feature, which is the ability for loops to know if we are exiting like naturally or if we are breaking away from the loop. And this is encoded in the else branch that you can add to this stuff. So yeah, let's go find where all these things are defined. So while break, while continue break. There we go. Break, like return, accepts a value parameter. This is the result of the while expression. When you break from a while loop, the else branch is not evaluated. Yes. So else is what ends up happening if we didn't break from the loop. So we can say we keep looping, and if we find we can do it like this. Row 1 is going to be the while loop. I need to remove a bunch of brackets. Oh man, this is going to be interesting. Oh no. What's going to happen with the else branch? Okay. Wait, okay, let's see how far I can get with this. Okay, so we keep iterating, and if b.data b.data, so the row means that we fix the outer parameter and we scroll the second parameter. So this is going to be x, and we are going to basically inherit the row number from the original number when we matched, which is going to be I. So I is going to be fixed. X keeps scrolling, and so if that cell not found is false, we break with false. Else we continue, But also there should be an outer else, which belongs to the while loop, where we say, so this else is what runs if we never did break from this. And here we return true. Bit of a clusterfuck. So last year, I think I found some cases where this was more nice to have. This is not maybe the best fit here, but the idea is we keep scrolling with a while loop. No need for else continue. I think the problem is that if I don't have else continue, this else true is going to try to attach to the if loop. That's my worry. That's why I'm specifying this. If I put you don't need the else continue, put braces around the while block. If I put braces, I need to label those braces then. Right? Let me think. I don't need braces here, or do I? I don't. Okay, let me think. If I put brace here, the break is going to work correctly? Yes. If I put a brace here, the continue is going to work correctly. Wait, but then how do I make sure that this just around the block, not around the while? Just around the block? Around the loop body, okay. I see what you're saying. Right, because this gets resolved with a break, not by returning stuff. And so we can do this. Understood. Okay, you're right. That's definitely nicer. Maybe this can go on one line? I don't know. I think that's definitely better. Thank you. So with this, we know if the row 1 we could do the same with the column. In the column, we keep changing row. We fix the inner parameter. X needs to be reset. And if any of these things have as 1, what do? We need to compute the... Oh, you know what? We need to compute the number of points. Also, by doing this version, we don't even need to write down the last match because we know the last match and it's what's being... It's the number that we just matched right now. We don't need to write it down. So I think this is a good point. We don't have to worry about diagonals. We only care about rows and columns. Oh my god. You're saying diagonals because part 2 has diagonals too. Is that it? God damn it. I don't know. If that's the case, I'll see once I get there. So... Oh, you don't remember. Okay, so that's fine. So if row 1 or col 1... we want to std dot const res is gonna be board dot count score, and we can pass in the number. So we were looking for an excuse to put a method to the board. I think this is a good excuse. Hey, Arkinia 90, thank you for the follow. And I think we're good. So let's do count score. Okay, so count score takes a board, takes a number, which is the last extraction, which is AU8, and returns what? Say a U size. So count score, we were saying, is var sum not found. It's a U size, a SUSY, versus 0. And let's copy the iteration code, blah, blah, blah. Oops. So, sum not found starts at 0. We keep iterating on the entire board, and const cell equals self data ij, and if cell.num equals no, we don't care about cell.num, we care about cell.found. If cell was not found, then we do sum not found plus equals cell.num. Let's see. I think I put the set of checks you just wrote inside a board. Function bingo bool. Nice, because you just return true instead of having to worry about breaking to the right place. I see. So the reason why I didn't go for like a method to check whether it was bingo or not, I could have done that too, yes. I could have definitely put that also inside a method. I don't know, I was busy copy pasting my row and column iteration code. So yeah, that would have been another reasonable choice, I agree. So so we do the sum of all the not found stuff, and then we return sum not found times is that it? Also, why are we passing it down? We could have multiplied stuff here, but whatever, who cares? This doesn't have to be good code. Let me see if I remember correctly. So, score of the winning board now needs to be calculated. Start by finding the sum of all unmarked numbers. Multiply the sum by the number that was just called when the board won, 24, to get the final score. Okay. Well. Big run. Use an client identifier board. Yes, I renamed it to B. And I guess I didn't do it everywhere. Where is this? Line 85. Is this still B? This is still B. Okay. Error is ignore. Consider using try or catch. Yes. So appending and allocate, and so that can fail. Cannot assign to constant. Wait, what? Oh, I see what's happening. B. Thank you, compile error. That would have been a terrible thing to find out. So here's the problem. Here I was being more careful about extracting a pointer from B so that it wouldn't copy the cell outside and then apply a side effect to a copy instead of the original thingy. But then I'm making the same mistake from the boards, from the array list. So with this syntax, I'm potentially copying the entire board out. So I need to make this a pointer too. Okay. So with this syntax, basically you say, yes, I want B, but I actually want a pointer to B, so that if I need to modify this board, I'm going to modify the board inside my array list instead of a copy of it. And, okay, not good. Definitely not good. There's something else wrong. But before we get there, what did I want to say? No, I didn't want to say anything else. Okay, so let's try to get a nose. What the heck did I do? So we get the number, we parse the number, we get the board, we update the board. Every time we grab a cell, if the number matches, then we set the cell found to true. Then we check the win condition. And the win condition clearly is not doing what I want it to do. And then what else? Let's calling count score. So this thing is returning true even when it shouldn't be returning true. And then what else? Oh, you know what? Also, this needs... So if we found the one, then we return. Okay, so this is wrong. Slightly less wrong, though. If not cell.found... No, okay, so for result to be 0, it means that basically we are never summing here. Because every single time... So yeah, something is wrong. I should probably print some stuff. Can you print the board in a nice way? Okay, time to see how printing the board looks like. How am I going to do this? I don't know, I'll just do it here. std.debug.print. Let's see. Is there... I think there's like a... How do you... there should be like a diagnostic print, right? Advent of struct. There should be a nice way of saying, yeah, please don't print this. Like, just go down and print everything explicitly. Is it... I don't know the syntax, though. I'm kind of tempted to say D for debug, but that's not it. Yeah, that's definitely not it. Add a format function. No, I don't want to do that. To JSON. Oh, actually, that would work. Yeah. Oh, come on. There should be like a full print, isn't there? Inside as a format specifier. I don't think there's a built-in pretty... I think there was. FMT. Oh, there we go. With question mark, the type informative function will be called instead of the default. Wait, what? With question mark being the type formatted. Oh, okay. So seriously, there is no debug specifier. That's annoying. Maybe it is the question mark though. I don't know why I'm so convinced that there was something like that. And maybe there was and just got deleted. Yeah, that's not it either. That's annoying. Okay, well, at the end of the day, you know what? it's fine because I only actually care about b.data. I don't really care about other stuff. Cannot format array without a specifier. Guess what? This is the only time where it's not a freaking string. Is D good enough for you? Okay, super ugly, but number is 75, found true. Number is 41, found true. Number is 53, found 2. 45, found true. 7, found false. Found false. I'm noticing something very sketch, which is that why are all the true numbers up here? Like there's a bunch of true numbers, and then it's false, false, false. I mean, that's possible, but it's kind of suspicious. Let's look at another one. True, false, true, false, 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 false. Why is there no true anywhere? So I think the logic there that does this stuff is wrong. Yeah, zero is a suspicious number because zero is it's 100% suspicious, but it's 100% also wrong, I think, because zero is a board where every single cell matched, and that's impossible because we must have had a match, like a winning condition before we got there. I think it's actually correct. Wait, what? No, I don't think that's possible. Don't you need to reset J? Francisco, I think you found it. Maybe. Let me think. Yes, I need to reset J. Thank you. I think we found the real problem. Thank you. It was nice to have like this initialization out there. Feel like this. Yes, I agree that eventually all boards are completely filled in, but the winning condition has to be met way before then for sure. Like, it's impossible to fill a board without having a while ago already had at least a row or a column being complete. So yeah, I think that's pretty much it. It's just me trying to be cute with variable initialization. Okay. Well, what do you know? There we go. Thank you. Okay, so at this point, the third board wins because it has at least one complete. Okay, for example, this puzzle is complete. Part 2, on the other hand, it might be wise to try a different strategy. Let the giant squid win. You aren't sure how many big boards a giant squid could play at once? Probably a lot. So rather than waste time counting its arms, the safe thing to do is to figure out which board will win last and choose that one. That way, no matter which board it picks, it will win for sure. Okay. In the above example, the second board is the last to win, which happens after 13 is eventually called, and its middle column is completely marked. If you were to keep playing until this point, the second board would have a sum of unmarked numbers. Okay, wait. This one I need to read more. In the above example, the second board is the last to win. Okay, that's fine. Which happens after 13 is eventually called and its middle column is completely marked. If you were to keep playing until this point, the second board would have a sum of unmarked numbers equals to blah blah blah. Figure out which board will win last. Okay, so I think this should be an easy change to this code. Should I make a copy to preserve the original? Oh, yeah, let's do it, whatever. Copy. This is gonna be main one, I guess. Okay, so basically what we're going to do is we keep doing the winning thing, but we need to remove boards from the array list. Yes. So here's the hardest part of this. What is the goal of this project? This is just a series of exercises called Advent of Code. If you go to adventofcode.com, just a bunch of exercises. It's like Advent calendar, so like they publish a new exercise every day until the 25th. And it's just to have fun. People use this stuff to learn new languages. So they basically give you a story and an excuse to mess around with stuff. If you mess with the array list, it validates the slice, right? Yes, that's the hardest part basically of this change. So we need to make sure that that doesn't happen, which means that we can't really use a for loop. But we need to use something else. I think we need to use like an iterator. And do array lists have iterators? Iterators are invalidated on resize. They're not invalidated when you remove stuff though? I mean, we can read in the documentation, right? So, where is it remove? Function delete? I don't know. Do you remove stuff from is it pop? Pop. Remove and return the last element from the list. Invalidates pointers to the remove element. They aren't technically invalidated, but they may skip elements. What if you store the count of numbers that takes a board to win? That's actually another nice solution. Yeah, I think counting... Francisco is giving great suggestions, I think. We can count. Yeah. We know how many boards we have in total. And that's it. Just mark the board as has one. Yeah, we can keep count, I guess. So so as we extract numbers, are we in the right function? Yes. So as we extract numbers, okay, before we get there, var remaining boards is boards.count, which I believe is just a property that I can access, right? No, we have capacity. Init, the init, blah blah blah, insert slice, append. Oh, items on land. Yeah, I'm dumb. Yeah. Thank you. Yep. Okay, so we have the remaining boards. Then every time a board wins, you check the winning condition, but check the winning condition. So we subtract from that count. And if there are no more remaining boards, or rather, if there are remaining boards, so if it's greater than 0, then we don't do the count score thing. But we just continue. Is that it? Oh, wait, we need to break, actually. We need to break. We are done with this board. We move to the next board. So we want to break here. I don't know. Why did I decide to do this? It's the same as breaking to row loop, right? Do we do anything else in here? Yeah, it's the same. So you know what? Let me change this. I don't know why I decided to do a different thing. It's basically this. So we're done checking this board at this point. We don't do anything else. And we're good, right? Maybe only count score if it's the last one. Yep. Okay, did I not remove this? I did not remove this. I want to remove this. Thank you. Okay. Oops. Okay, let's see. That's not the right answer. Okay. Why is this not the right answer? Are you skipping already finished boards? Ooh, fuck. You're right. I'm not. That's the problem. Yep. And that's why we also really need to write that down. Yes. Also, here's a food gun. So I'm adding 1 as a bool, which I want to set to false. But if I give it a default value here, here I'm initializing the board to undefined, and that initialization won't happen. So that's a problem. So let me go back to the original initializer, and now I can actually do this, and it's gonna happen. Otherwise, my boards are gonna be like nothing will make sense. Okay, so 1 is false, and so here, so if this thing won, then remaining boards is -1, and b.1 was true, and then if the board has already won, we skip it. Expected comma found semicolon. Yes. Missing field data. $49.20. Okay. There we go. Yay. How about score usize null and pubdon self bool? That also would have worked. Yeah. I mean, you just need to write something down, right? Okay, number 5. You come across a field of hydrothermal vents on the ocean floor. These vents constantly produce large opaque clouds, so it would be best to avoid them if possible. They tend to form in lines. Submarine hopefully produces a list of nearby lines of vents, your puzzle input, for you to review. For example, 09. Is this like run length encoding? What is this? Hey, iridescent. Okay, so 09 to 59, 80 to 08, these x and y coordinates? Yes. So each line of ends is given as a line segment in the format x1, y1, x2, y2. Coordinates of one end of the line and the other one coordinates of the other end. Okay, cool. These line segments include the points at both ends. In other words, 1, 1 to 1, 3 covers points 1, 1, 1, 2, and 1, 3. Okay. An entry like 9777 covers points 9, 7, 8, 7, 7, 7. Oh god. Where are diagonals here? Okay, for now, only consider horizontal and vertical lines where one of the two coordinates is constant. Cool. So the horizontal and vertical lines from the above list would produce the following diagram. There's a 2. Also, there's a 2 here. There's like a 1, 2, 3, 4. Is there like a something 4? Something 4. 1, 2, 3, 4, 5. Oh, x is the first coordinate. Okay, so that's 4, 5. Where's 4, 5? Oh, it starts at 0, so that would be 3, 4 then? Where's 3, 4? 3, 4. 3, 4, 1, 4. 0, 1, 2, 3. 4. And then 1, 4. Oh, I see. Okay. So these are like different segments that have like small overlaps. Somehow I was convinced that this was like a very tiny line with like just 1 point. No, these are like overlapping segments. Okay, cool. So in this diagram, the top left corner is 0, 0, and the bottom right corner is 9, 9. Each position is shown as the number of lines which cover that point, or dot if no line covers that point. Cool. The top left pair is the top left pair of ones. Pair of ones, top left pair of ones. This one, okay. For example, comes from 2, 2 to 1. The very bottom row is formed by the overlapping lines of 0, 9, 5, 9, 0, 9, 2, 9. Okay. To avoid the most dangerous areas, you need to determine the number of points where at least 2 lines overlap. In the above example, this is anywhere in the diagram with a 2 or larger, a total of 5 points. 1, 2, 3, 4, 5. Okay. Consider only horizontal and vertical lines. How many points do at least 2 lines overlap? So why is this repeating this? Do I already have like weird lines in my input? Actually, let me close a bunch of stuff. Do I already have like No, I think all my lines here are... Never mind. This is a diagonal line. Most definitely. So, okay, so there's also those and we need to ignore them. Okay, cool. Oh god, yeah, diagonals, we're getting there. God damn it. Okay, I need a very quick bathroom break and I'll be right back. Orc AFK. Yep, right back. Okay, let's do this. So, new day. Also, remove this. Oh. Okay, so we have our main file, our input data. Okay. I'm not doing Redis Labs marketing anymore, so you know why? Because I'm doing Tiger Beetle marketing now. I have a Tiger Beetle cap with a nice T logo. And I even have a Tiger Beetle sleeveless thingy. I don't know what's it called in English. Gilet? Do you say gilet in English? Or do you hate the French word for it? Never heard that. Okay. Best. So without sleeves, it's a vest. Oh man. Okay, actually, so I'm assuming, I think it's a French word, but apparently it's a thing that we use in it. I see a lot of Italian results. I don't know if they're like localized to Italian because I'm in Italy and I'm Italian, or if that's because it's just a French word that we stole. I would call it a sleeveless jacket. Okay, that works best. Yeah, okay, apparently, yeah, that's a vest. Oh, I see, but that's because you're thinking of those, right? I mean, Americans are definitely most thinking of like their high school attire. In the UK, a vest is typically what you wear under your shirt. Oh, okay. I think I know what you're referring to. What's it called in Italian? Oh man, I know what you're referring to. But so you're talking about this, right? Is this what you're referring to, Soap? No, a wife beater. Okay. Yes. Okay. Yeah, sleeveless undershirt. Yeah, it even has a name in Italian. There's a funny name for it. There's a funny locution for it in Italian. Yeah. So basically, there's like this meme. I don't know that like old Italian grandmas always tell you that you need to wear this under your shirt, otherwise you're gonna get sick. And so they call it like the thingy of good health, something like this. Anyway. The British called okay, so we have a bunch of points. I think this is a good excuse for a point strat, no? How big do our points need to be? Oof, 958. That's a lot. That's a lot. We'll go with U size, U size. Let's go with U32. Let's be data oriented. Let's go with U32. I mean, even if I make something smaller, it's still gonna be padded out, right? I think. No, it gets padded out to... I don't remember how padding works. Whatever. U10. So U10, this would at the end get padded out to what? So let's say that I put 2 U10s in here. That would be U20. Does it get padded out to 24? No. Because 24 is not a power 2. It has to be a power 2, right? So basically we'll get padded out to 32? I don't know anymore. Somebody explain computer science to me, please, in chat, as I try to solve the puzzle. Okay, so we don't need that anymore. So we have our points. Var it equals std lamp tokenize u8 input. Oh, here's something interesting. So here's something interesting. I think we want to tokenize on a new line, but then we want to split on something else. That's going to be interesting. So, no, we still want to tokenize. It's tokenized all the way down. So let me show you how to cheat with tokenize. People at this point, maybe like sane people, or rather, like the standard approach to this problem would be that you kind of would want to have like regular expressions at this point, maybe. But with tokenize, you can still get pretty far if you know what to do. So let me show you how to cheat this with a single tokenize call. So we tokenize on new lines, but then we also tokenize on commas, and we also tokenize on spaces. So look what happens once we do all of this. Tokenize on new lines, commas, and spaces. And now, while it.next, so what do we call this? This should be x1. So basically the idea is that by tokenizing on all these characters, we are gonna get this as a token, this as a token, this as a token, which we're going to skip, then this as a token, this as a token, and then the dance restarts. So by tokenizing all this stuff, here's what we're gonna do then. X1 string, let's call it string. So we're going to do const. Why not tokenize on this also? Because you cannot tokenize on a sequence of characters. These characters are all put like in OR, so it's gonna split on new line or comma or space. If you want to like split on the arrow, you have to use something different. But here's the point of what I'm trying to say then, that if you have something more powerful that allows you to express this, you can do it. You can do it with regular expressions. Like I think the most general way of doing this is like regular expressions, or maybe a slightly powered down version of that, like just patterns. But actually, you can get away with not having to do that. Just use tokenize, because what you're gonna do is grab this. Oh my god, let's not mess it up. You're gonna grab this, then grab this, and then you ignore this one. And you can do that because you're tokenizing on spaces. Would tokenize not only remove that arrow and leave you with numbers? Oh, I see your point. So you're saying you add the characters in OR. That's kind of weird. Will it work? Will it not return empty slices? I need to... Okay, I see your point now. I would need to read the documentation. Will it return empty slices or does it skip empty slices? If it skips empty slices, I guess it's gonna work. It feels kind of dirty. Tokenize doesn't return empty slices. Okay, so if it doesn't, then I agree. You're right. You can put that. I don't know why it feels weird to me though. So you know what? I think I still kind of prefer to just skip this one. For maximum ugliness. Nice. It's cool though that you can also do that. I feel like it's a dangerous line of thinking though. This is just from a first impression, you know, I wasn't thinking of that solution, so maybe it's actually perfectly fine. And it works. But in the past, basically, by skipping strategically tokens that are part of regular structures, I think you end up with a solution that it's actually not hacky at all. It's actually almost as intended. Okay, so x1 is going to be try std.fmt.parseInt. We said u32s. Okay. What? x1 string base 10. Then we do the same with x2, y1, y2. And in the middle, we skip the arrow. Okay, so x1, x2, y1, y2, and this dot question mark. Okay, so with this we are basically parsing everything correctly. And it's kind of cute. Then we need to do so we need to compute overlapping coordinates, right? This is going to be interesting. How do we compute overlapping stuff? The original exercise kind of suggests that you basically build a matrix and you use that matrix to build stuff. But here's the thing, the numbers go up kinda a lot, maybe not insanely so. They still stay down to 3 digits, which is, I guess, kinda nice. It means that we could create a matrix 1000 by 1000. That could work. Or we could go for the sparse approach. So with the sparse approach, we wouldn't need to have a matrix 1000 by 1000. We would only need to store coordinates that we care about. Is it worth going for the sparse approach? Or should we just power through with the 1000 by 1000? I mean, 1000 by 1000 isn't even that big, right? Oh, thank you everybody for providing a link to Zig. Yeah, it's a systems programming language, so I'm using Advent of Code as an excuse to show people how to do stuff, or I don't know. There's actually not a lot of pretense in how I'm solving the solutions. Like, I'm not saying that this is how you should solve anything. So I'm figuring out as I go. But it's an excuse to show people a tiny little bit of the standard library, how to get by with doing stuff, and how memory allocation concerns relate to the Advent of Code solutions, which arguably are not the best match for systems programming, except when it comes to brute forcing solutions, where, like in Python, it would take, I don't know, 45 minutes, and the same highly inefficient solution takes, I don't know, 3 seconds in Zig, because you're not doing heap allocation everywhere. Hey, Lobsang, hello. Okay, so I don't know. Should we do hash map or giant matrix? I'm kind of thinking of doing giant matrix. Normally, I would try to be like conservative and try to just do the argument in favor for sparse. You're going to have to look for heights greater than 2. I think there are better ways of doing this, you know? I'm trying to think, like, I don't know for sure, I would have to think more. But the whole approach of having a matrix where you plot each dot seems kind of naive. I think there's probably a much smarter way of basically saying, of having an engine that understands where that, like, basically you apply a transformation to 2 strings somehow. Sorry, strings, two lines. Like you somehow compare lines, and through that you understand how many points overlap. But I don't know how to do that correctly out of the box. Argument in favor for matrix. You're going through 1 megabyte of data is cheap and fast. Yeah, that's true. So here's what I'm gonna do. I'm gonna do the matrix for one reason. The hash map syntax is annoying. And if I don't have a strong incentive to use hash map, then the array syntax is just easier. And I think that if you're just iterating over stuff, yeah, let's go with the matrix approach for now. Let's see how it goes. Okay, so we have our matrix. Our matrix is going to be var space. Our space is going to be how many points in the data file? I don't know, a lot. In terms of points, a lot, because I think that some of these lines are kind of long. Which is also why I was thinking that probably, I think there is like some processing thing that can be done to like eliminate some things. Like for example, you can do it in some kind of process of elimination. You take one string and you compare it with all other strings. If there is no overlap, then you know that you can toss that string away. You take another string, check for overlap. If there is a partial overlap, you basically you shorten the string to only keep the partial overlap. And move to the next string. So you see, so you basically don't think of this as a matrix of points, but you solve this analytically. Like you compare each string to all the other strings, and whenever there is no overlap at all, you just toss away the string, or you shorten it if there is a partial overlap. And once you've gone through all the strings, like once you do a full pass of the entire string set, what remains is all strings that only have overlaps. N square compares. I don't think it's is it an N square compares? Yeah. Well, I mean, you are shortening stuff as you go. Well, wait, it's not N squared. It's like, I forget the precise formula, but it's like, it's one where you only look at strings downstream. Like, once you process this string, you don't touch it anymore. You only go downwards, I think. Do you? Let me think. No, you can't. Because you will find... okay, so wait. And if you do find an overlap, what you do is... here's another way of making it nicer. So you look at a string. No overlap with any other string, you toss it away. You look at another string. There's a partial overlap, only a small piece. You shorten the part that doesn't overlap with anything, and you toss it away. So you shorten the string, and you remove the overlap part from the other string. So that basically the overlap part goes into this one string, and that's it. And then what else do you do? Then you keep scrolling down. Is there a way of avoiding having to look at the strings up above? I think you can avoid having to look at the strings up above. So basically what ends up happening is it becomes like a n time, I don't know, n minus 1 divided by 2, something like this. I don't know. But I think this is another valid approach that would probably work and be nicer in terms of memory than having to keep a matrix around. I don't know, it feels, but okay, let me put it this way. Maybe it's not worth in this case because the exercise is nice and the strings aren't, and the lines aren't super long. But if you had like giant lines, you wouldn't want to have a giant matrix, and probably you want to move to sparse. But even then, you would have, like, if you start storing point by point of your line, you might end up with a ton of points that you don't need. So, yeah. Well, I mean, okay, fair, but, I mean, matrix is not, doesn't seem that much better. Again, it depends. Like, if these lines were super short, like, imagine that all these lines were, like, in a matrix, I don't know, 200 by 200, then you can see how, yes, maybe it's not worth it. But then instead, if you had super long strings, then definitely the more analytical approach would be better than the matrix. Many of the lines are very long. Robin made a nice visualization of his input on the Discord. Oh shit. So Specs, has anybody gone with the let's shorten the strings approach? Is that a damn idea? What if you don't do the matrix thing? Am I going to ruin my second part of the exercise? I was only half paying attention. So what I was saying is the exercise seems to immediately point you towards a direction where you basically end up storing every point everywhere. And I guess you have the choice of going for a matrix or for a hash map for a sparse approach. But then there's also, so what I was saying is an algorithm where you don't do any of that. And what you do is like you look at the first line and compare it with all the other lines. If there is no overlap, you toss it away. Then you look at the second line and you try to find overlaps. If you do find an overlap, you basically, what you end up doing is like you shorten this string, you shorten this line to only become the overlap. So you toss away the parts that don't overlap with anything else, and then you move to the next one. And you keep doing this until you reach the end. And basically what you should have at the end is only the segments that overlap with something else. At which point you can basically count the points of the remaining segments and you have your answer. So basically you go for an approach that doesn't require you to store each point individually. It's more analytical, I guess, to some degree. And we were discussing that maybe in this case it doesn't make much sense to do, like it's not worth it. But if you had like super long lines to the point where it's absolutely not worth it to store individual points, not even in a sparse way, then maybe this would be the way to go. And I was wondering if part 2 pretty much wanted you to have built a matrix approach, or if it could be reasonably solved also by this other weird approach. That might be fast. That's definitely not simple. Yeah. I also know of fast approaches. Oh shit! Like that's the game knowledge part. I think part 2 would be solvable either way. Okay, I'll do the boring thing, but I think messing around with strings a little bit could be fun. I keep saying strings when I mean to say lines. I don't know why. In my mind, they're kind of the same thing. Okay, off topic, but what Christmas playlist is this? It's very nice and chill. It's called It's called Christmas Ambience with instrumental Christmas music and crackling fireplace 24/7 Christmas carols. Interesting idea, however, I'm not sure. That one is not easy to write. Oh, I think it wouldn't be that bad. I think it wouldn't be that bad. I don't know. Should I attempt it? Man, this is a potential for a lot of pain. Should I try to do the weird approach? Don't recommend it. Okay, I won't do it then. If Pex says don't recommend it, then I won't. I think it was fun, even just thinking about it. Like, what's nice about these problems is that there's sometimes they point you towards a direction where there is one way of modeling the problem. But in my experience from doing like research, oftentimes that's a very tempting trap, and like taking a step back and reevaluating the problem from scratch and think of a completely different model for solving it sometimes really lets you find out funny things. Okay, so we have our space then, and we're gonna make our space 1,000 by 1,000, right? Also, you can do this, which is nice. What do we put in its cell? I don't know. How many lines do we have? 500 lines. So 500 is the maximum value that we can find here. I don't know, whatever. Let's do U32. Good enough. So here's the problem, though. Okay, so I think what we want to do is this is the type. And then no, we don't specify the type. What we do is we assign std mem.zeros. Oh no, I think it's zeros like this, right? This should work. Let's see what people are saying. Most of the intersection will be single points anyway. Oh, you don't care if they're greater than 2. Right. I don't know. I'm kind of thinking... For now, I don't, right? And I can change this later. Okay, good point. So what do we make this? A byte? Let's make it a byte. They'll give you a brute force option, but also the input usually makes that unfeasible in practice, so you have to make a more optimal solution. Yeah, but that depends on what you're trying to achieve, right? In this case, I'm guessing sometimes like going from a matrix to the sparse solution, that's your good enough solution that it becomes that the computation is solved in like a second or something like this. But there are multiple dimensions where that can happen. So at U8 is gonna be 1 megabyte, which would probably fit in L2 and be fast. With U32 it's 4 megabytes. Yeah. Good point. I don't know how much L1 I have on Mechem1. $12 megabytes. Oof. Two bits should suffice, I guess. Whatever. I don't think it's gonna change. Yeah, so like apparently I can put a lot of stuff in there. Maybe we could. Would it make sense to try to fit this in L1? Would it work? 192 plus 28k per core. That would work, right? So if I make this, can I expect this to actually stay in L1 if I do this? You are on one course on 198. Wait, I think it's 192 plus 128k per core. Is it like, okay, I don't know how this would work. We'll pad per byte, right? So we need packed int array. Right. I'm not doing that. It's fine. Okay, to have our space. Also, hey Wami, thank you for the follow. Welcome to the stream. So we got our points, and then I guess we need to ignore diagonals. So if x1 is different than x2 and y1 is different than y2, so if neither coordinate stays stable, then we skip this. Then we store points. So is there a nice generalized way of doing this? I think yes. So var I starts at x1. Var j starts at y1. I'll remember to put the j inside the while loop. Okay, let's see what people are saying. Probably 192k of data plus number instruction cache. Oh, that's L1 instruction cache, and 128 is data cache. Okay. There's a trick to stay mostly in L1, which is what the fastest solution does. I mean, you can probably, if you you can probably, so instead of storing a bunch of zeros, you could probably somewhat run length encode this stuff, I guess. Maybe. And use that information and modify that. You know, I think that there are a ton of C implementations of data structures that I could lift from Redis, and they would make like very nice solutions for a bunch of this stuff. Because all these bit fiddling tricks, like they do run length encoding as long as the thing is not too fragmented. They're all implemented in the Redis. I should probably steal some code from there. Okay, so my cursor starts at the starting point, and then while I is lower than y1, we keep incrementing I. Oof. Do we keep incrementing? We don't always keep incrementing, right? Because it depends on... Wait, are those lines always from lower to higher? They're not. This definitely is not. So, what's a nice way of explaining, of doing like this linear interpolation stuff? So annoying. So this is easy. I can cheat and make this different then. So as long as it's different, we keep trying to move there. No. Is this seriously it? Specs, please. You make games. Is this really it? No, don't do that. Okay. Oh, man. Would it make sense to make a function that changes the value by 1. You know what? I think I'll make a function. You can't stop me. Okay, if you make games, you might not want to watch this. I enumerated the case in my solution, but not all 4. What if I make this? Does it even make sense to point both? Does it make sense to do this? I think I'm overthinking this. I could put like an if statement here, like an if expression, and say I could do this. I plus equals, and if also, why am I doing y first? That should be, wait, that should be x2, right? So I starts at x1, has to end at x2, and if and when we change it, if x1 is greater than x2, we add -1, else we add 1. That would work. So maybe I don't need this. Oof, adding -1 to U size. Oh my freaking god. So what you ended up doing is that you started from the lowest one and then went to the max, I guess. That's probably the best solution. I think that might be the best solution after all. Okay, so that would how would that look like then? That would look like I guess it would be like std.math.min, I think, between x1, x2, and then const I max. Actually, I use sign for everything. Okay. Okay, well, imax is going to be then std.math.max between x, x2. And so I needs to go until imax, and it only increases by 1 regardless. Oops. So let me see if this makes any sense. Okay, we start at this coordinate. We know where we have to go. It's the other one. Then we keep increasing to get there. Cool. The other value, it's basically constant every single time. So we don't really need to do anything there. But there's gonna be diagonals afterwards. So I might want to generalize this immediately, or maybe not. You know what? I don't need to generalize this immediately, so I could just copy this. That's gonna be J. Be Y1, Y2, Y1, Y2. J. J max. There we go. And so if we do end up entering this while loop, what we're gonna do is set stuff in our space, right? Yes, so space. We want I outside. I don't think it matters much, but whatever. IJ plus equals 1. And actually give it up here. And then we do the count, right? We count how many are greater than 2. Line 38 still says IMAX. Oh, thank you. That would have been a compile error, thankfully, but yeah, thank you. Also, I don't think I need to specify U size. Or actually, I think I do, because I'm parsing these as U32s. That's gonna be interesting. So if I don't specify anything, these are gonna be U32s, and okay. I think I'm gonna get a free promotion if I just say U size here. I hope. Okay, so we have this. Wait, why are those... Wait a second. Are those actually U32s? Yes, why are those U32s? Why did they make them U32s? Oh, because I have a point data structure here. And I don't care about this. So originally I said, oh, maybe I do need a point data structure, but actually I don't. I actually don't need this. Oops. So this whole U32 thing was just an idea in the beginning, but then I actually don't need a point data structure. So let's remove a bunch of type annotations that I don't need. Okay, so we do this, and then finally, we do the full count. So here's what I'm gonna do. I'm going to put the store point stuff inside a block so that I can reuse I and J. So while I is lower than base.len, I guess. We keep increasing I. And we do the same with J. And I can use len twice because it's a square, so I don't care. J plus equals... Okay, let's see. By shaving the size of my store counts to U8, I just got my resolution down to 0.006 seconds. Cool. So we do the same with J. And then what do we do in here? Here we count, right? So var danger points. We have danger points, and so if space position ij is greater than 1, then we do danger point plus equals 1. And then finally print danger points, I guess. Okay, that works, I guess. Maybe. Let's find out. Let's see the programming errors. There's gonna be a bunch, of course. Icon identifier J. Where? Line 29. Oh, right. Ooh. So I don't have a J in there. And I don't really have an I in here, but here's the idea. Basically, the idea is that if these two are different, then the Y's are the same. Oh man, I should really generalize this. I should stop messing around. Let's just generalize this. Is this correct? No. This needs to be lower than IMAX. Oh man. No, you were so close. Yeah, why? I mean, okay, so this one doesn't work because when it's constant, like basically here, if I and IMAX are always the same, then it's not gonna work. But I kind of would like to have like a one iteration for this, I guess, but I don't have it. I would like a do while, which I don't have. The original code doesn't have this problem, but it's a hack. Actually, I should stop trying to optimize for a problem that I haven't seen yet. So whatever, let's just hard code the other coordinate in here and fuck it. So there's gonna be, if these coordinates are different, then it means that the y1 and y2 are the same, and here it's kind of the same reasoning on the other, like the opposite side. Unused local variable allocator. Oh, cool! I didn't need the allocator. That's fine. Container std mem has no member called zeros. Is it? Zero as it is result 0 result 0. Okay. Wait, why am I printing in, wait, what? Okay, so wait a second. I should calculate danger points only once we are done with all the strings, I would say. Once we're done with all the strings. Oh, which means that actually I didn't need this block here. Yeah. Okay, result 0. Nice. No. There's something wrong. Why did it only print twice? I think it printed only twice before. Yeah, why did it print only twice? That was interesting. I think it printed only twice because we were skipping a lot of these. Maybe I'm skipping when it's wrong to skip. Let me do this. std debug.print ports. Let's do it like this. So I'm basically recreating the original input, but at least I can see that being done correctly, I guess. So x1, 2, y1, wait, no, x1, y1, 2, y2. Okay. So these numbers seem reasonable. These numbers seem almost reasonable. Oh my god, am I giving wrong names to the variables? Is that it? Oh, uh-oh. I think I'm shifting the numbers around in the wrong way. That's because I'm so dumb. That's x1. So the same problem that I had here is the one that I had here from before. So x1, y1, x2, y2. Okay, so that's more correct. Did I do this stupid thing also elsewhere? This is correct. 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 This is also kind of correct. I don't like this, but it is correct. I think, and I think everything else should be fine. So maybe I can also remove that print. Five, 2, 6, 1. Oh no. What was I doing? How should I time this? Oh, this has 800. Okay. So people were timing the result, right? Let's see how much time this consumes. So zig build dash o release fast in the zig. Oh, it's not build. It's build dash xe. Okay. Now I have main. Do I have time? Express a command from the end of statement. Okay, time main. Yes, dot slash main. Result, blah blah blah. External user time. Okay, I don't know how to read this. Somebody compare this with all the other results. And also let's double check that at least the result is correct first. Is this it? That's not the right answer. There you go. Nice. So I have some mistakes in there. Let's check that we are now reading the lines correctly, at least. Yes, yes. Yes. Okay, so now I'm reading stuff correctly. Yeah, I don't know precisely the difference. I have no idea. I can spoil the bug. Oh, you see the bug. Okay, give me a sec. Try the sample and print out the grid for it. You will see the error in it. I see. Okay, give me a sec. Let's see if I can see it like this. Oh, I think I know what it is. I think it's not different. It has to be greater than, right? Because the extremes, I think, were also included. So that's probably it. That's my guess. No, result 0. Oh shit. What have I done? It's not different. It's lower or equal. I think that's it. 5581. Let's see. Oh, that's not the right answer either. Oh shit. Okay, should I try the sample output? Maybe I should. Maybe I should. So annoying. But this was an error, right? Because I need This needs to include also the maximum value because the extremes were included. Yes. Okay, give me a second. Let's see if I can reason about this a tiny little bit more. Oh, damn it. But now, by allowing them to be equal, I have reintroduced the problem where I'm going in there when this coordinate stays stable. God damn it. So we do this loop only if x1 is different. The next two. Is the if going to combine with my while loop? Expect a semicolon else found var. Line 31. Oh, because it becomes an expression. Neat. And this is the same with a y. I think I found the problem. If y1 is different than y2, then we do this. Beautiful expressions. That's a code that I like to see. It's terrible. 5294. Let's see. Yeah, Matt, thank you for the follow. Hankdon, thank you also for the follow. D Vigodev, thank you. Welcome to the stream. What was it? Number 5294. Yay. This thing where the extremes are included, it's so annoying. I think a do while would have solved this more nicely. First try, by the way. So a do would have helped, but it's this weird condition here because you have to start from a different position, but then also the equality is included. That's like it's a pesky request. Yes, it's a pesky problem. Okay, let's look at the diagonal stuff. Okay, unfortunately, considering only horizontal and vertical lines doesn't give you a full picture. You also need to consider diagonal lines. Yeah. Because of the limits of the hydrothermal vent mapping system, the lines in your list will only ever be horizontal, vertical, or a diagonal line at exactly 45 degrees. In other words, okay, considering all lines from the above example, we produce the following diagram. You still need to determine the same thing, so now it's diagonals. Let's go. Okay. So, ignore diagonals goes away. I hate this exercise. It's stressing a tiny bug in my brain that should not be there. So we don't ignore diagonals anymore. We now have a different case, right? Because so here by saying these two have to be different, we're also implying that the other two are equal, but that's not the case anymore. I tried to write the iterator and decided it was not worth it. It becomes very inconvenient with the inclusive endpoint. So but what if I actually kept J? So what if I really kept J and nested them? It's the stupid equality thing. Okay, so you know what? If those are different and those are equal, so in this case, this code is still correct. in this case, this code is correct. And so what we're missing is the final case where all are different, right? So if all are different, then what do we do? So we know we can do the I iteration, I guess. And in there, we need to do the J iteration, I think. Let me think. We have to do the iteration, but we never have to reset J. Do we? No, we never have to reset it, so it's fine. We can just do this, maybe. Is this it? You know, I'm kind of tempted to just YOLO try it. I think this is fine. Time to YOLO try it. Ah! God damn it. So this condition is correct. I think everybody made the same mistake, I see. Now let's see what this same mistake could be. So I keeps changing. Oh. Why am I nesting these while loops? They shouldn't be nested. There's no nesting. It's just kinda also, we know that they're always 45 degrees, so okay, so we can cheat basically. We can say, yes, we use I as the condition, but then we also increase J. But maybe you need a semicolon there. Oh, wait, what? Oh no, why is it not returning to the original? This is correct. Is this correct? No. Expect a semicolon. Okay, so I do need to put a semicolon in here. Okay, that's fair. So here's what I'm doing basically. This is weird syntax. Probably if you want to do this at this point, you might not want to put it here as the continuation expression. But you at this point, you probably want to put it as a normal expression in the body. But yeah, it works. Let's go. Is this gonna be it? Oh, that's not the right answer either. Ouch. What if y2 is lower than y1? It should not matter because I always sort them the right way. So I put a point, then I add 1 to this, which moves, I think, the x coordinate. Then, oh, wait, plus goes down. Is this the problem? Is plus that should not go down? Yeah, I should probably invest more in debugging tooling. Yeah, MIE Yo-Yo, thank you for the follow. So you turn 3-1-1-3 into 1-1-3-3, I think. You turn 3-1 into 1-3. Andy, thank you for the raid. Okay, let me try to understand this. Okay, so let me try to think this from scratch. So the first iteration correct? I is set to x1, j is set to y1, or whatever the lowest number of those is. Oh shit. Okay, yes. I can't swap them independently. No! I can't swap them independently because otherwise it's gonna give me coordinates that make no sense. Yes. Oh no. And there are cases where I have to, god damn it. No, I'm not seeing anything. I'm just being a moron. So this whole thing where I was swapping coordinates around to decide where to start from was nice in the beginning, but it's not nice in the end where I'm basically allowing this thing for there's a particular configuration of coordinates where swapping around doesn't work because it breaks everything. Still at that day, yes. Hi Annie. I started late because I was away from home when the Advent of Code started. Yesterday I did the first 3 exercises, and today I'm doing the remaining ones. You just make a point map, but I know what the problem is. The problem is that this approach, where I basically swap around coordinates so that I can always do +1, just doesn't work. That's the problem. That's my problem. So this kind of served me well a little bit in the beginning, but now this approach is falling apart when doing this. So here's what I'm gonna do. Since this keeps working for everything else, I see I do another language each day, so I have one I haven't managed to solve yet, but yeah, I see. Cool that also that you're doing different languages. And also, by the way, I don't know if you ever tried Zig. If you haven't, consider that one too. I warn you, it's a systems programming language, so it's not going to be the best tool for most of the Advent of Code problems, but it's interesting. Which, by the way, is what I'm using right now. Okay, so here's what I'm gonna do. In this case, I'm going to ignore all these variables, and I'm gonna make my own ones, I think. So do I go back to the if expression? Do I go back to the if expression and do the subtraction stuff? Oh man, if there's a line at the 0 coordinate, I'm going to underflow. I should really do iSize like Specs were saying. Do I just really do iSize and then I cast iSize every single time? Or I could shift by 1 and then subtract 1 afterwards and then assert that it's gonna be fine. Oh, so many awful corner cases. So I recommend doing while true and put a break on it. So while x is... Yeah, also my condition. God damn it. So I think I want an if statement also in here. Like if x1 is greater than x2, then we want to do x lower than x2 or equal. Else. Oh yeah, Max, I'm doing it. It's terrible, isn't it? Else x greater than or equal x2. Oh my god, this is horrible. This is truly horrible. Also, why is this not formatting? And I want to do x plus equals if... I think I will have to make them I size, I think. Oh my god, this is gonna be so much of a problem. I was trying to do the stupid thing, but it's stupid behind past any reasonable... no, there's way too much stuff to write. Okay, I'll do the while true thing. God damn it. While true. Specs space xy is incremented by 1, and then x, and then if x1 is greater than x2, or actually lower than x2. Alex Twitcher, thank you for the follow. So if x1 is lower than x2, then we increment x. Else x minus equals 1. And we'll see if Zig has to complain about this. And then we do the same with y, I think. And also I think we can make this a one-liner. This should work. So yeah. Goodbye. Okay, y. Okay, I'm looking forward to see how Zig is going to complain about these operations. And then, what do we need to do finally? We need to find a break condition. What's the break condition? The break condition is that x is not in this range anymore. So if x is... Okay, it depends still on this condition, so I need to repeat this condition basically. So, okay, we are in the case that x1 is lower than x2. So in that case, if x is greater than x2, then we break. Else, if x is lower than x2, then we break. I think this is how... try putting the break somewhere else in the loop might be easier. I mean, I could put the break inside here, but I wanted to keep those in one-liners. I don't know. It works though, right? I mean, I'm repeating a bunch of logic, but whatever. So this should work, except when we underflow. So what do we do when we underflow? Oh my god. Yeah. So your point is we put the brake before doing the operation so that... Is it possible though? Yeah, it's gonna happen for stuff that's close to the border. Like if there's a line close to the border, we're going to have trouble. Ah, my beautiful one-liners. No. Ah. Okay, so in here, if x1 is before we do anything, we do this. Before we do anything, we do this, I think. Let me see. So if x1 is lower than x2, then we want to increment x, but if x is already outside the range, we break before, or wait, it's equal. We break. We can break on equal here because we've already incremented. So yeah. No need to modify those, they are good, keep the one-liners. Oh, so you're saying move everything above. Yeah, you're right, I could have done that too. I'm getting tired. Right, so is this correct? Maybe? Time to find out. That's the right answer. Yay. Okay, we done day 4 and day 5. Should I uptemp day 6 too? I think I should also uptemp day 6. How long have I been streaming for? 3 hours. Ooh. So, I could try to do 6 today and tomorrow maybe 7 and some of 8. Should I try super hard to catch up? Day 7 is super quick if you want a fast one. Should I do them out of order? I don't think I want to do them out of order though. So maybe tomorrow 6 is very fast too. Okay, so let me do a bathroom break super quick. And then I'll do the A6. So let's see how it's gonna be. Be right back. For the people that don't know, that's not T, by the way. That's the inverse of T. I leave to your imagination. Okay, I'm back. So what did I miss? Day 6 is either very fast or very slow, depending on how you think about it. Awesome! For me, 6 was only fast on the second try. If you don't crash your editor, because you used the wrong solution. Oh shit, okay. Okay, let's see how it goes. Day 6. The seafloor is getting steeper. Maybe the sleigh keys got carried this way. Massive school of glowing lanternfish swims past. Let's look at the lanternfish. Okay. They must spawn quickly to reach such large numbers, maybe exponentially quickly. Oh, I love that word, exponentially. You should model their growth rate to be sure. Although you know nothing about the specific species of lanternfish, you make some guesses about their attributes. Surely each lanternfish creates a new lanternfish once every 7 days. However, this process isn't necessarily synchronized between every lanternfish. One lanternfish might have 2 days left until it creates another lanternfish, while another might have 4. So you can model each fish as a single number that represents the number of days until it creates a new lanternfish. Okay. Furthermore, you reason, a new lanternfish would surely need slightly longer before it's capable of producing more lanternfish. 2 more days for its first cycle. Okay. So here's a funny observation that has not much to do with the algorithm itself, but while these concepts here, are fine for the puzzle, I think there are some forces where animals that behave like this, they have a big incentive in trying to synchronize with everybody else. Because usually what these animals want to do is like come in waves, because there's a lot of protection that you can get by being just a big number of individuals. And you can see that also happen on multiple scales. Like I think one particularly neat example of these are some types of what are they called? What's the pronunciation? Cicada? Cicada? What's the pronunciation of cicada? Cicada?
Cicada.
Cicada. So cicadas, there's a type of cicadas that have like this multi-year loop where basically for a few years there aren't a ton of these things. Like they try all to spawn at the same time, but there's like a limited number. And then after a few years, they have this huge explosion where there's a lot more individuals that spawn all at the same time. And the logic behind this is that if they were to maximize the number of individuals that come out every year, they would basically sustain an equivalent population of predators, because they would basically feed these predators every year. So what they do is that they keep those numbers artificially low so that the number of predators stay balanced to that number of individuals that come out every year. And then after every few years, they have like this overpowering number, which basically ensures that there are not enough predators around to eat all of them. And that year for the predators, it's like it's a holiday because they get a ton of these things to eat everywhere. But at the same time, there's so many that basically they end up being able to reproduce and do everything else that they need to do, whatever cicadas do before dying, which I think is just reproduce, not much more. In any case, okay, so you can model each fish, new lanternfish. Yes, so suppose you have a lanternfish with an internal timer value of 3. After 1 day, it goes to 2. Another day goes to 1. Another day goes to 0. Another day goes back to 6. Oh, I see that we are going 0 index. Okay, cool. And it would create a new lanternfish with an internal timer of 8. After another day, the lanternfish would have an internal timer of 5. And the second lanternfish would have an internal timer of 7. Oh my freaking god. I can already smell it. So if there's an analytical solution to this stuff, it's probably this stupid Chinese reminder theorem somewhere or something like that. Like if you want to skip like the simulation and just go for analytical solution. That's how it smells. I don't know if it's 100% correct. Okay, another fish that creates a new fish resets its timer to 6. Not 7. Okay, never mind. No, there are too many weird rules. Then no, it's not gonna be the Chinese remainder theorem then. Because 0 is included as a valid timer. Oh no, wait, no. That's the original reset thingy. The new lanternfish starts with internal timer. Oh yeah, there we go. It's the new lanternfish that has a weird rule. So the Chinese remainder theorem doesn't apply clearly to this. Okay, so it does not start counting down until the next day. Realizing what you're trying to do, the submarine automatically produces a list of the ages of several hundred nearby lanternfish, of course. Your puzzle input. For example, suppose you were given the following list: 3, 4, 3, 1, 2. So this list means that the first fish has an internal timer of 3, the second fish has an internal timer of 4, and so on. Okay, so next day this one goes to 0. Then when it goes back to 6, we get a new fish. This goes back to 6, we get a new fish. Okay. So one thing that you can do, I guess, is that I don't know what it is that you can do. Okay, anyway, you can simulate it, I guess. Each day at 0 comes a 6, hence a new fish, blah blah. In this example, after 18 days, there are gonna be a total of 26 fish. After 80 days, there are gonna be a total of this much. Find a way to simulate lanternfish. How many lanternfish would there be after 80 days? Puzzle input. Oh shit. Okay. There's a lot of ones in here. There's a lot of ones. But I think I think you can like you can probably have a set of stupid substitution rules to how many days? After 80 days. So you can probably simulate basically these ones in groups, right? All the ones that are synchronized to ones, they're all gonna be basically the same fish. And you could argue that also, like, and you can make the other ones do the same. Like the ones that are synchronized to 4, you can put a counter there. How many there are of that type. So no Chinese remainder theorem, but at least you can. How did you see it so quickly? It's like, I don't know, it's like their equivalence classes. I don't know. I guess a computer science degree, at least a bachelor ones, helps a little bit seeing these things. It also helps not knowing how to program well though. So like choose what you want to be good at. So let's do the equivalence classes stuff. Let's go. MKDeer. Day 6. Touch everything. Input. Oh god. So you see, I can do this, but I can't copy paste. Because I always forget that on Mac is command and on Linux is control. And I do always the opposite or whatever, it's the wrong thing. Okay, so do we need an allocator? Do we need an allocator? Answer is no, because we know beforehand what the buckets are going to be. So we are basically doing, so here's the thing, we are doing some kind of transform for our simulation, right? By doing equivalence classes, it's like it's not exactly transform, kinda though. It's kind of like like it's a like a, well, it is a transform. It's like a Fourier transform, but without sine and cosine, so no Fourier. But it is a transform. There's also other funny ones. Like, jokes aside, like the concept of a transform, if you're not familiar with it, it's pretty cool. There's also the another one. It's the Burroughs-Wheeler, I think, transform. I don't know if I can type it anymore. Burroughs-Wheeler transform. There we go. This one is another funny one. It's basically you're just reorganizing stuff in a different way. This is useful for like compression, I think. Well, whatever. I think the point is transforms are a useful concept to know. Let's copy some stuff in our main.zig. Let's copy these two. Okay, so well, let's call them buckets. And our buckets are gonna be, so how many buckets do we need? We need 8 buckets, right? Not using the data section of the example can sometimes be very useful. Yes, like when the exercise is about you finding the nice solution versus not the naive solution, then yeah, they will purposely not show you, like they will purposely show you the naive version. They won't show you what the better version is, I guess. So okay, so buckets, we only need, is it correct that it is 8? Yes, it is 8 buckets, I think. Do I want to become famous? No, I don't. Bork, Ben, but thank you for helping out with Bork tests. Danny, 781. Goodbye. 0 Inex, so I needed a 9th bucket. My brain can't reason this far. Okay, let me start doing this. I'll probably find I'll probably encounter the problem fairly quickly. Okay, so what do we put in there? We put the number of fishes, right, in that bucket. So let's do a Suzy. Should be a U size. I think it's fine. U size it is. And also we want to set it to zeros, so we can do this, I guess. Or like 1. Times 8. That's another way of zeroing data structures. Or rather arrays. Okay, we have our buckets. Hey CodeMonk, how's it going? It's going pretty good. So we have our input. Basically, we need to put each of these fish in the right bucket. So we want to split on the comma, right? Yes. Is there a final new line? There's not even a final new line. That's so cute. So we split on commas. So while there's a next number. Oh my god. Okay, I found it. Okay. Const num equals try std fmt parse int usize token base 10. You did a lot of progress today. I'm doing my 3rd exercise right now. Okay, so oh my god, is this optimization going to bite me in the ass in the second part? I hope not. Okay, so we parse the number. The number tells us where this fish needs to be put. So if it's a 1, then it need to go to 0 next. Let me start again, sorry. Another fish that creates a new fish sets its timer to 6, not 7, because 0 is included in the timer value. Realizing what you're trying to do, blah blah blah. Where's a new another fish will certainly be longer. 2 more days. So yeah, this is a bucket with ID 8. You're right. We need 9 buckets. Okay, I finally saw it. Like when you tell me, it's not like I don't believe you, but the problem is that if I don't internally understand it myself, so I need to get there, and I think I got there now. Okay, so we get the number and we put it in the right bucket. So buckets num plus equals 1. So we load all the fishes and then we run the simulation. So var I equals size equals 0, or we can do it backwards. Let's do the number of days. So 80 days. Oh my god, this is gonna be the usize with subtraction. It's not gonna work. Okay, let's start from 0 and add. goddamn usizes. So while I is lower than what's gonna be? I think it was 80 days, 90 days. How many days? 80 days. So for 80 days, heading to lunch. Might be back later. Thank you very much. Have a good lunch. I plus equals 1. So what do we do in this while loop? We need to simulate. So we need to basically bring all the fishes down 1 level, and the ones that are at 0 need to wrap to the right position, and we need to add the new fishes. So, oh my god. So we start with slot is gonna be buckets.len, I guess. Well, -1. This is another subtraction thing. God damn it. Why do people find day 6 easier than day 5? I thought day 5 in under 10 minutes, day 6 took running much longer. I don't know. Day 5 was kind of annoying for the all the off by 1 errors and stuff like that. And I think in my specific case, Zig really makes it annoying when you're trying to subtract from a usize. So you know why? So you know what? Why am I making this a usize? No, wait. I need to make this a usize though. Or I could make it a I size, and then I subtract and I cast it, and I get a panic if I get it wrong. Yes, you know what? I'll do that. I think Specs is right in just being more liberal with adding signed stuff. Thank you, Annie, for the follow. Okay, so our slot starts as the last one. Can I do minus? Oh, you know what? I think I don't even need to do that in this case. Now that I think about it. So I start at the last one. Last one. So I need to basically move every fish in there to one below. You might want to take a look at STD mem rotate. Ooh, I like that function name. Was I inside mem? No. Ooh, STD mem rotate. Thank you. Rotate. In place rotation of the values in an array. Oh, yes. That's nice. That's nice. So 0, 1, 2, 3 becomes 1, 2, 3, 0 if we rotate by 1. Oh man, that is so nice. Except... No, that is so nice. There is no except. Thank you. I love this. Oh man. Thank you, Specs. I wouldn't have known that that was there. Okay, so we have our thing. Do we want to immediately rotate it? So here's the problem. Rotate will do the right thing for every fish, which is higher than 0. The fishes at 0 need to reset to 6. They instead will be put to 8. So we need to move these fishes from 8 to 6. But they also generate new fishes that are right to stay at 8. So we basically need to copy 8 into 6. And that's it. Is this really it? Holy shit, is this really it? So we want to rotate, what's the signature? Rotate type, items amount. So we want to rotate type, view size, buckets, pointer to buckets, obviously, yes. And we want to rotate once, and then we want to do buckets. We want to copy buckets 8 into bucket 6. And that's it. Copy as in add. Because the new fishes, every fish produces a new fish, right? Yeah, that goes into bucket 8. And that's it. Yeah, Spec saved me a lot of pain. I mean, well, not a lot, but a reasonable amount. Because he basically implemented rotate for me by pointing out the standard library. But that's good, that's good. And, okay. I think we can, and then what do we need to do? Print the total number of fishes, right? How many lanternfish would there be after 80 days? So we do this, and then const, well, press size equals 0 for buckets B, press plus equals B. Std debug print. That's it. Okay. Oof, not even compile errors. Holy shit. Am I doing an off by 1 error anywhere? I'm doing 80 days. All the fishes keep rotating. The ones that get to 0 duplicate. And that's it. Okay. Oof, right answer. Thank you, Specs. I would have probably needed a couple of tries if I had to implement rotate by myself. I can definitely see that. I see one bug, however, I think you will find it. Well, the solution did ended up working, so what's the bug? I don't think I see a bug anywhere from that perspective. Okay. Okay, let's see part 2. Suppose the lanternfish live forever and have unlimited food and space. That's usually a bad combination. Would they take over the entire ocean? Yes. What do you mean? After 256 days in the example above, there would be a total of how many fish? Oh, this is the part where you get punished if you didn't do the buckets, huh? Uh... Okay. Oh, that was so nice. Thank you, Specs. I feel there's a math equation that you could run to figure this out. I don't think so, because there is the irregularity where new fishes go into the 8 bucket rather than the normal 6 bucket. I think that if all fishes went into the normal 6 bucket, maybe you could do something with that. But even then, you have these... So the question is not like a statistics question. The question is precise on the precise number after a precise number of days, and you have all this integer math with fishes that could be different numbers divided into different buckets. So I don't think there is like a closed function definition for this. That's my impression, but I might be wrong. Fn equals Fn minus 9 plus Fn minus 7. If they have unlimited space, can they ever take over the entire ocean? Interesting question. That's a good point. I feel like if you do this in a lower level language, you immediately go for an array, as you don't want to allocate, but in higher level languages, people naively append to a list over and over. I don't know about this. I mean, I can see this partially as one way of looking at it, and I'm sure that partially this influences people's decisions. But on the other hand, I mean, at least in Zig, we do have array lists, and they're pretty nice to use. Like, you just append to it. You don't even have to think much about it. I think the difference, like, at least in my case, the way I looked at this was not from my lower level language experience, but was from my computer science experience. Like, the moment I saw this, I immediately started thinking about equivalence classes. So that was my personal way of going at this. But I guess it depends on your background and the way that you use to approach problems. I think also that there is I think there's also a maybe it's not a hard rule, but I suspect that most of the times Advent of Code probably tries to put you in a situation where a problem becomes untractable from a computer science perspective more than the language that you chose perspective. Because I think that they design it to not punish people based on the language that they chose. So they'll probably go for stuff that definitely requires to rethink stuff. So I don't know. For my input, I would have needed 1.7 terabytes of RAM for the list approach. Nice. Yeah, that's cool. Well, I think I'm gonna stop here. So we did 3 exercises yesterday. I did 3 exercises today. Hopefully tomorrow I can do 2. People said that 7 wasn't particularly bad. So hopefully we can find a cheat solution also for that day. And so let's see you all tomorrow, I guess. Thank you for stopping by and watching the stream. Thank you, Specs, for the mem rotate. That function was amazing. Precise, like mem rotate, tokenize, split. I think mem is my favorite file in the standard library. Thank you also for other people that made suggestions and helped with stuff. Well, let's see if there's anybody that I can raid. As usual, none of the people that follow the programming are streaming right now, of course. Let's see if I can find somebody else quickly. Let's see. I want something like systems programming. Oh man, I always miss the people. C game dev. I think C game dev is pretty good, so I'll go with that. Let's start the raid. Well, thank you everyone, and see you tomorrow for more Advent of Code. Bye bye.